So far I've only shown photos of my loco from the right hand side, so here's one from the opposite side. I've decided to add an extra video part, part 3C. This part 3B video will describe the mechanical construction of the gearbox and the problems of fitting it. Part 3C will complete the loco mechanics and describe the cosmetic modifications. I was unable to find anyone else who had built an electric 9F, so unlike people who build steam-powered locos, I had no guidance on how to proceed. OO gauge electric locos were little help, since they had no suspension to cope with, and if there was a motor in the loco, it drove the fifth axle, which I wanted to avoid. However, I used to lecture on electronics and electric motors, so I was confident regarding those aspects of the project. Part 3A has already explained the principle of the powertrain that I decided upon, and now this part 3B goes into how the principle was turned into a working system. The biggest problem was ensuring that when the gearbox was built, it would fit into the firebox area of the boiler. My lack of drawings was touched on in part 3A. Measuring such an awkward internal shape was difficult, especially since when the boiler was on the chassis I couldn't see into it. I had to fall back on lots of cardboard mock-ups. Unfortunately, apart from this simple example, they've been thrown away and I don't have any photos of them. Before plunging into the gearbox construction, I'll briefly show again the principle diagram from part 3A. I've just found one of my early diagrams superimposed on a boiler diagram of a different 9F, so I'll put this up. Once I was reasonably confident that the outline shape would fit in, I started on the detailed design. I like to work in pencil on a 5mm squared A4 pad. This is the general assembly as viewed from the front of the loco. I will show the photos in a moment. To aid the description, I've coloured in some details. The plates were cut from 5mm aluminium, shown here in blue, and drilled together to ensure alignment. The motor was mounted on subplates bolted directly to either end of the motor. The main plates were spaced to be a sliding fit on the inside of the loco frames. The plates were held in place by threaded rods, which was great for adjustment. Another plate was added later to protect the 140-tooth nylon gear when raising and lowering the superstructure. Square inner plates were bolted to the main plates to provide extra support for deep grooved ball races. The main shaft was to be in a 12mm diameter ground bar, but it wasn't available, so I used 12mm A2 stainless, which fitted okay. Once the shaft was fed through to ensure alignment, I Loctited the bearings to the plates with Loctite 638. The shaft was centred with bushes. The bush next to the 140-tooth gear had a disc-shaped section so that it could be drilled and fastened to the gear with 4 M5 bolts. This bush was eventually secured with a 3mm roll pin. The bush at the other end was later fitted with a 4-arm flag, detected by an infrared slot sensor to provide synchronism for a sound generator. The 18-tooth gear was initially left unclamped to ensure it was well aligned with the chain, but eventually it too was secured with a roll pin. The next diagram shows the arrangement of the two identical Delrin chain followers. The rollers are on ball races and are mounted on M4 A2 threaded rods with spacers and nuts. The outer nuts are nylock and are fitted, leaving a gap to accommodate the ends of the tension springs. The swinging arms are fastened to short shafts, which can rotate in plain brass bearings bored with lubricant holes. This diagram shows the arrangement of the rear 13-tooth idler gear and its swinging arm. The idler is fixed to a shaft which rotates in ball races. The swinging arm only moves when the chain is adjusted, so it has simple plain pivots. One end of the adjuster has a right-hand thread and the other a left-hand. This allows the adjustment to be made by turning the long centre section and then securing it with lock nuts. Here you can see the adjuster, the swinging arm and its pivots. It all needed to be very rigid. The front idler arrangement is very simple and shown at the bottom of this diagram. The 13-tooth sprocket is mounted on a 10mm shaft which runs in ball races. It's centred by bushes, one at each end. The plates shown above this are the ones made to widen supports for the ball races. This photo shows a front view of the gearbox. You can see the chain passing behind the front idler and the Delrin follower. It also gives a good view of the follower swinging arm and its springs. Here you can see a rear view of the gearbox with its plates and threaded rod construction. If you look along the main shaft from the nylon gear end, the first thing you see is the disc bush that it's bolted to. Next comes the 18-tooth sprocket and chain, and beyond that another bush. On the far side of the plate the view is obscured by connector B that carries the sound wiring. Just visible is the edge of the board that holds the infrared sensor for the sound synchronizing flag, which is mounted on the end of the main shaft. The shaft to the left of the main shaft acts as the pivot for the chain adjuster swinging arm. Between the two shafts and at a lower level are the two springs that tension the chain followers. At the far left is an assembly that will be described later. To enable investigation of the fit of the loco superstructure over the gearbox, I was going to need to lift and control it relatively easily. I made a strong wooden structure that went right down to the floor to support two lifting systems, one at each end. The lifts consisted of 1 metre lengths of 16mm threaded rod, fitted with flattened tubular arms that contained 16mm nuts tightly hammered in. The arms rested on greased metal surfaces. At the front, a cord went down through the chimney and around a short longitudinal piece of wood in the smoke box. At the cab end, I made a sort of hook that went down into the top of the coal hole. The system works quite well, but the 2mm pitch of the rods makes it a bit slow in action. However, the arms are quite heavy, so that when they're not under load, they can be spun. A level was quite useful to keep the number of turns at each end roughly in sync and save counting them. Adjusting the position and angle of the gearbox to the frame was very tricky. I lightly clamped the gearbox in place, and since I couldn't see the boiler clearances directly, I used an eBay borescope to examine the situation. Looking in from the smoke box end of the boiler was not much help. Eventually I found a position that satisfied the clearances and left the bottom of S4 at the right height from the track. I tightened the clamps and carefully lifted the superstructure out of the way. The next step was to drill right through the loco frames and gearbox plates before bolting them together. I don't have a photo of this stage, but it was at this point that I fitted the plate to protect the 140-tooth nylon gear from damage when raising or lowering the superstructure. This shows the superstructure about to be lowered onto the chassis. This is a suitable point to stop Part 3B, but the loco mechanics and cosmetic changes will continue in Part 3C.